Hi guys. Hi everybody. I'm sorry for the delay. I got my Mac OS reinstalled. Well, actually upgraded to the latest version, and my camera capturing software stopped working. It's a very classic situation. So I had to install something else in just a few minutes. Apparently, I managed to get it working, and now we are live. Thanks for coming. Let's go to your questions. As usual, it's a 1-hour session. You ask me questions, I answer, trying to be as helpful and as honest as possible. We spend 1 hour. Questions about project management, software development, career development, maybe startup, maybe life philosophy, but everything around programming, because I'm a programmer myself. Question number 1. What do you think if I master the basics of Java, Spring, Git? Will I be able to do an internship in a company, a local bank in Central Asia, or is this no longer possible? I think internship is what every company would be glad to help, because the interns, they are basically free or very cheap resources, and at the same time very enthusiastic. I believe every company would love to have you on board, as long as you don't have too much, as long as you don't ask for too much money, and at the same time you're ready to work hard. Be brave, just apply. Second question, will there be object-oriented programming lectures for Russian audiences? Have you encountered procedural programming in Java? It is possible, but I have to say that it's quite difficult to read lectures about technical things like programming in Russian. I even tried a number of times in software conferences, and it always sounds quite weird. It's quite hard to translate every single technical term from English to Russian. That's why I try to do technical lectures in English, while lectures about philosophy, open source, and everything like that, management, that's Russian language is fine for that. Next question, how to write a scientific article? Can you give some advice? I'm probably the wrong person to ask that question, because I have very limited experience in doing that. Even though I'm trying to become a scientist, and I hope that in the next 10 years I will become one. But so far I'm very immature and very young as a scientist. But I do have some advice about how to write scientific articles, and I published those advice on my blog, and you can find probably so far maybe half a dozen of blog posts where I explain how to do that. But in every one of those blog posts, I provide quite a lot of links to other blog posts, to other YouTube videos and books sometime, which recommend how to do that. I highly recommend you to read a book which is called How to Write for Computer Science. And I can give you the link to this book below after the video is finished. That book helped me a lot. I don't remember the name of the author, but the book is amazing. It's easy to read, easy to understand. It gives you the idea of what needs to be done in order to make your writing correct. What I've learned so far over the last 4, maybe even about 4 years of academic writing and failing, is that the structure of your writing matters way more than the essence and the subject you write about. The readers and the people who accept your writing, they care way more about how you deliver the information versus what you deliver. Probably because there's a lot of people around computer science who write not such a high quality content as readers would expect to read. That's why they filter out a lot of papers automatically. And if your paper is not structured correctly, then they're not even going to pay attention to what are you talking about. How to structure, it's not so difficult to learn. It's not a rocket science. It's not something that is, it's not art. It's pretty well-defined set of principles. You put something here, you put something there, you mentioned this here, you mentioned that there, you start from here, you conclude there. All of the things, they must be in place. And if those things are in place, then you will be published. I'm not yet that good. I'm not being published frequently. I actually get a lot of rejections for my papers, unfortunately, so far. But give me 10 years, I'll get there. It just takes time. It's practice. You need to practice a lot. Next question. How is it important to understand what serverless is and which tactical design decisions it makes us to choose? Serverless in general, as far as I understand that, it's the, but I may be wrong, but that's my understanding, is the way you design your application, having in mind that that computational resources are not available in right where you need them. They are available somewhere, but let's put it this way, they live their own life to some extent. And your job is to connect those resources to each other and to help them communicate with each other and synchronize their messages, synchronize their information, and then somehow orchestrate that whole thing of entities which behave and talk to each other and produce information, consume information. It is different from a classic, let's say, three-tier client-server architecture or three-tier architecture in general, when you have the one layer which directly connects to a lower layer, and then when something is needed to the higher level, for example, layer, to the presentation layer, then you just connect to, let's say, directly to persistence layer and just get the information from the database and deliver it to the customer. In the serverless architecture, you assume that the information is not available right where you need it. You need to express your demand, express your desire to have the information, and then somebody in the network of resources, they will understand that somebody needs the information and they will put it somewhere where you need to get it. So let's say you get an image from the customer and that image needs to be resized. So in a classic design, you just take that image, save it to the database or to the file system, and then you call another function in your application, in your Java application. The first function just gets the content, receives the content, the binary file of 100 kilobytes. Then it stores the 100 kilobytes on disk. And then you call another function which will take that 100 kilobyte, resize that, and then immediately deliver to the user back. The user just goes to the website, clicks the button, upload the image, and then waits for a number of seconds, and boom, the image gets resized. Or for example, you scan the image and you, let's say, apply some modifications, AI, whatever, and the user gets back the image. The user is happy. That's the classic design, the classic architecture. In a serverless, you get the image, you design the web front, which is hosted on some server. You don't even know the name of that server. You just put the piece of Java code on Amazon somewhere. You just give them the jar file, and then you configure the name server so that all the requests from the user, they will get there. And the job of that part will just take those images and store them to S3, Amazon S3. That's just one part. Just get the image, store to the S3, and that's it. And then you configure the notification mechanism in Amazon, which will trigger the event when the new object appears on the S3. So the event is triggered, and by triggering that event, you start the lambda function, which is another process, maybe not a Java, maybe written in Python. And that piece of Python code on another place in Amazon will just pick up the S3 content and will do the pre-processing, for example. And then if it's done, the pre-processing, it will put the new content to another place in S3, to another bucket. And then another event gets triggered. And then another Lambda function gets started. And that function takes the pre-processed image and starts the, for example, the pipeline in the EC2, for example, starts the machine on the EC2 if it's like something which is hard to work with. For example, it's a large task for AI processing. So you start a real server and still you don't know the IP address of the server because you automatically, when the server is started, you just push there the script which will download the new content from S3, do the processing, and upload the new content again maybe to another bucket. And then another Lambda starts and it takes that new bucket and delivers to the content delivery network in the cloud front, just pushes it there, and then it gets updated and the user gets the link and downloads the content from the server which is closer to the customer. There are like 5 or 6 ingredients, 5 or 6 elements in this pipeline. Instead of one server, you just have 5 scripts which stay separately one out of another, and they don't know about each other. They just communicate through the data storage, through the data bus. And you need to design those 5 elements. You need to test them somehow. You need to create integration tests for them. You need to orchestrate this whole thing. You need to be able to test this pipeline because they need to do all of that should happen quickly. And Amazon will guarantee you that all those triggers, they will just immediately get started and Lambda will work fast and everything will be fast. But the whole pipeline should be orchestrated and synchronized. But then if you have that, you have zero problem related to scalability of your application. You don't care anymore about the cost of your infrastructure. You just don't care about the number of servers. You get one client every second, or you get 1 million clients every second. Amazon guarantees you that you're going to start as many those Lambda functions as possible. So now you start designing your applications as a collection of micro scripts, not even microservices. They're not microservices. They don't have IP addresses. They don't need to reply to any requests from the outside. They just live their own life individually, having their own lifetime. They start at some point and they finish at some point. The question is how to test that. I believe this is the core trouble right now, how to put all of that in sync. But that's the future. That's 100% the future. We're not going to have web applications in 10 years. It's just this technology is just dead. It's going to disappear. There will be no back end and front end. There will be just micro scripts. And they will be like 50 lines long. They will be short. And the biggest question will be how to orchestrate. That's what I think. There will be no infrastructure, no IP addresses anymore. You will forget how to connect to the database. There will be no such thing as establish a connection to the server. You will only talk to the API of Amazon. That's all you're going to do. And there will be some sort of orchestrators, maybe they exist already, I just don't know them, but there will be some systems which will help you to see how this whole system works, what's the traffic, how it goes, and all that. Okay. I told you everything I know about serverless architecture. I actually have some experience and I probably will write some blog posts about that in a few months. But now I'm also investigating that. Unfortunately, too late. I should have been started, 5 years ago. But I tried a number of things inside those concepts, like some sub-elements. But now it looks like I'm getting to know a larger picture. Next question. What's my opinion about Mikhail Gorbachev? Okay. Mikhail Gorbachev. I saw a number of movies that, conspiracy movies, of course, which claim that this guy, the leader of, the last leader of Soviet Union, that he was actually the sort of an agent of CIA. So not an agent, but he was, how do you call it when you hire somebody from the enemy side, and that guy works for you, like not a spy, but somebody, basically an agent. So he was it was the plan to have that situation, and properly orchestrated plan by United States, which, as we know, succeeded quite well. So that's my opinion. I don't think that guy was personally somehow a smart leader or an evil person who actually intentionally ruined the country. The country was moving to the collapse step by step for many years. And I remember that country. Maybe most of you don't remember Soviet Union, but I lived there for like 15 years or more of my life. And that was a country which was not so nice at that time. As in 1950, 1960, that was a different country when my parents were young, and they remember something else. The country was going to the collapse thanks to internal problems, maybe thanks to external confrontation. But this guy was just whether he was consciously doing that or he was not smart enough to understand that he's being guided and he's being promoted by external forces. I don't know. Well, in the movie which I saw, that was the movie by Leonid Mlechin, which I highly recommend you to watch, where he demonstrated how step by step Gorbachev was going to power. And there are many questions to this road. Like, there are certain events where his opponents, they were losing power, they were dying for some reason, and Mlechin speculates on that, asking questions whether it is just a coincidence or maybe not. That's what I can say about that. Next question. I'm experimenting with ML and GitHub repositories in order to implement my research paper. I faced a few problems. What do you do in these cases first? Well, if you have problems, you just keep solving them. I think that's, maybe you can reformulate the question, but problems is part of research. If you wouldn't have problems, there would be no research. That would be easy, or that would be done already. That's the idea of research. You formulate research questions and then you try to answer them, I guess. Next question. Have you ever had some connections with money people when you did some business? If so, please tell us your experience. Yeah, the money people, you mean investors, the people who give you money and then you ask the money back. Of course, I had experience with that people, and well, usually these people are not they're not different than any other people, I believe. In general, I believe that that money people are just well, it's a huge amount of luck. That's first. This is what makes them money people. I kind of like to play poker sometimes, and I play for money sometimes, and I see people sitting at the table who win, and I see people who lose, and this is the micro simulation of real life. I believe the poker game, the money poker game. This is how life works. There's a lot of chance, a lot of luck involved. You may come to the table with a lot of money and leave the table empty. Or you may come with nothing and leave the table as a winner. But the next round, it could be the other way around. It's very little guarantee that the same poker players will be successful continuously. They lose. It's a lot of luck involved. But at the same time, some pattern we may notice among those people who lose more frequently than others. They are less anxious, less greedy, I would say. They're less, usually less aggressive. They just very, I would not say calm, but I would say maybe stable. They just more or less expect bad things and good things to happen, and they take them with less emotions than other people. And that makes them, I think, more successful on the long term. People who are quite aggressive, they usually win faster. But if you play with them on a tournament, then you're not going to see those guys at the end of the tournament. You're going to see them at the beginning, and you may become the victim of them. They may kick you out of the table, those aggressive guys. You better stay away. You better try to avoid confrontation with them. If you see that they raise, you just try to walk away, usually, because these guys are aggressive, but eventually they get kicked out on the tournament, and they go back. They try to rebuy. They try to bring back some chips, and they play again if the tournament allows that. But they never make it to the final table. The same with the money people. I think it's just these people who are less ambitious in general. I think it's a myth that if you're ambitious enough, if you're aggressive enough, if you're assertive, if you're direct, if you know your goal, if you follow that, then you're going to be successful. I think it's not how it works. Usually those people who achieve something, they didn't really want to achieve big results. They were just going with the flow. There is an opportunity, you just follow it. The people tell you that this is how it's going to be. You say, okay, if you say so, this is how it's going to be. You follow with the flow. This is the main strategy of money people. And then when you meet them, then the best way, I think, is to look like the guy who is ready to listen, to look like the guy who is ready to follow the rules, to follow the order that they will give you. And that gives you a chance to get the money. If you present yourself like aggressive, assertive, principled, brave, then you just scare them, because they see in you those people who get kicked out at the first rounds of poker tournament. They just understand that eventually you're going to hit some problem which will be stronger than you, and that stronger problem will just kill you. So what's the point of betting on you? You should look like cautious guy, like the guy who is scared of problems and tries to avoid them. That's what I believe. And this is why it's so hard for me to deal with money people, because I usually lose in poker. That's my problem. Next question. What are your top 3 reasons to use composition over inheritance? And should this principle be meant during an interview when talking about inheritance in self? Top 3 reasons. Well, composition is better than inheritance, first of all, because it's more... because in this way, you can reuse components more freely. The inheritance hierarchy is very strict. It's very solid. It's very hardwired. As long as the class is there, then in order to reuse this class, you only need to make a subclass from that class. But what if you don't need to stay in this particular leaf of the hierarchical tree? What if you want to be somewhere else? Then you have no chance to reuse that. I think that's one of the reasons. Composition lets you take whatever you want, any object you want from anywhere, and just encapsulate it, and that's it. You reuse the functionality. It's quite practical reason. The second reason I would say that in the inheritance you deal with things that you might not expect. Well, if the class is properly designed, the class that you inherit, then all the methods there will be final, except the methods which you are supposed to override. But usually people don't do that. People usually allow all the methods to be overridden, and you might override some of them by mistake. And by doing that, you're going to break the functionality of the parent class, which is going to be your functionality. That's called the problem called the fragile base class problem. You can Google it. It's quite known problem. When the base class is fragile and you inherit from that, then your class becomes fragile, means unpredictable behavior. That's the second quite known problem of this of the inheritance. And number three, I would say that well, because maybe it will be hard to test your class if you inherit from your parent class, because it will be hard to mock the dependency. Basically, your class now depends on the parent class, and then parent class depends on its parent class. All of those things are your dependencies. And now you are testing your class, which you deal with. You want to mock dependencies. You don't want to deal with the whole chain of dependencies. You want to just cut them loose and just insert something which is going to fake them. But you cannot do that in case of inheritance. In case of composition, you can, because your class basically uses another class as a dependency. You can easily inject a mock there. How are you going to mock the parent class? It's just technically impossible. And that's why you deal with large monster classes in the end. You just take a class and there are 50 methods there. Like 45 of them, they're inherited from somewhere. Now you want to test those 5 methods, but those 5 methods, they depend on the 45 methods. But those 45 you cannot remove. They're going to stay with you forever. That's a trouble. Those are 3 technical problems I see. Maybe there are more. Next question. Have you heard about Coursor? Which IDE do you use? I don't know what is Coursor. I assume it's an IDE. I'm using IntelliJ, IDEA from JetBrains for Java development. And I'm using Community Edition. I actually had the full edition, Enterprise. I had the open source license, but they declined to give me the license this year, even though I had it for maybe 6 or 7 years straight. They give licenses to open source developers. But this year, I applied for that, but they said the rules are more strict this year, so no license for you. Because it was not about Russia or whatever. It's not a political decision. They just said that the project which I commit to I must be the top 3 committer, but I'm not in the project which I submitted. And then I submitted another one, and that one they said the project is not so popular. So that's something like that. So anyway, I'm using IntelliJ. It works quite fine. But I can tell you, I'm using maybe, 2% of the functionality of the IDE. I'm just using it as a text editor. And all I need from the IDE, is just suggestions of the method names. That's all. Actually, this feature, if that feature would exist in Sublime Text, which I use for everything else, for tech documents, LaTeX documents, for Ruby programming, Python, JavaScript, all the programming languages which I use aside from Java, I just use plain text editor, Sublime Text on macOS. But for Java, because I want those method suggestions, the name of the methods, when I type something, I click dot and it suggests me the method name. And then I use IntelliJ. But that's all. I never debug. I never run. I don't even know where is debug button. I don't click it. Just no debugging. I use command line to run the scripts. So I run Maven and all the builds from the terminal. What else the IDE is for, I don't know, honestly. To manage the tree structure of the files, for that I use command line MC Midnight Commander. So I don't know why people are so obsessed about the IDE. The Copilot, I tried it a number of times. In my opinion, it's useless. It doesn't help. So I wouldn't say I recommend, but I believe that a plain text editor makes you a better programmer. I would claim that way. Because you kind of stay closer to the code. And again, let me repeat it. I don't know what IDE is for. Maybe I don't know. And also, you may ask me the Git. I always use Git from the console. I never do any graphic Git, whatever. I think it's just, aside from code review. But the code review is provided by GitHub. If you want to do the code review, if you want to send me the code that you created, you just send it on GitHub. If I want to see the changes I made in the code, I just in the console say git diff, and I see the difference. Maybe I'm just old school, but really, honestly, guys, I don't know what IDE is for, aside from the code completion or code suggestions. This code completion it's called, right? Next question. I'm a senior software engineer at my company. Company forced me to point that I'm a head of engineering on LinkedIn, but it's not a full truth. Now, and you companies don't want to hire me as a system software engineer, or senior software engineer. That's an interesting story. Head of engineering. Well, you can change that, right? You can go to LinkedIn and change your title and rename if you are. I don't know what to tell you here. Well, look at what's more profitable for you. If you care about your current company, then keep the title, stay with them, get their salary, be loyal. If you don't want to be loyal, then change the title, go to another company. What else can I say? Next question. When should you agree on the salary level? Before the interview or after receiving positive feedback? Well, dude, that's a tough question. Depends on your situation. Depends on where you are now and are you comfortable. Of course, it's way better, in my opinion. But I may be wrong. Don't take my advice, because I'm a lousy employee. I have very bad, history of getting jobs. I actually have mostly negative answers from companies like Google, Amazon, and all that. But I think that I would respect if somebody comes to me, let's put it this way, and I'm the employer, and the developer, the programmer, an engineer comes to me, I would prefer that guy to start with the key question, like, how much money do you have for me? And in that case, I would respect that person way more than the person who is dancing around saying, whatever, we're going to pass the interview, we'll see after that. I understand in this case that the guy is not confident, is not sure about his own skills. So what's the point of wasting time and talking and spending time on the interview if maybe my budget is not enough for you? Let's get the first question first. How much? And if that candidate asks that question upfront, I know that he's strong. I know that his position is strong. I know that he's going to hang up the phone right now. He can't do that if I give him the wrong number. That means that he's not needy. He's not desperate. That's my personal attitude to the situation. And I'm trying to do the same with sometimes with the companies who call me and say, we're gonna offer you something. I just ask them right up front, how much? And they get offended and they just walk away. Those recruiters, those headhunters, and all those guys. Well, some of them give me the number, but usually they give the number in a very large range. They just say from here, from $0 to $1 million a year. And I say, yeah, like, then I mean, in that case, it's just it's the end of the conversation. But sometimes they give me the lower bound. They say, we're going to pay you something or more. And then it becomes interesting. So if you are strong, if you currently have a job, and this is the best situation to go to the interview, any book can tell you about that. Any career advisor will tell you that the best position, the best interview is the one which you have while having another job. And if you have that, then you can just go there and say, hey guys, let's not waste our time, because now I'm getting this amount of money. Is it possible in general to offer me more? If not, then let me get back to work. And if they say, yes, we can offer you more, that's why we're here. We're trying to buy you because you're a resource for us. You're going to do something for us. You're a slave, basically. It's a slave trade. So we're going to buy. So the first question, it's money. How much? I cost this much. But again, if your position is weak and you have no job right now, then be careful. Don't tell that. Don't ask that question. Just wait until those those guys will spend enough money to prove to their management that they actually are worth something, that they need to be in this company, that they're getting money, they're getting their salaries for something. And then they dance around, they spend a few hours on all those interviews, and in the end they will tell you the number. Just wait for it. But you understand, you are being used. I mean, not used, but you are being humiliated all that time. That's true, but what can you do? You're weak. You have no choice. Just take it and hold it. Next question. Sorry, scrolls down. Okay, it's in Russian. My name is Artem. I study in this university. Aside from programming, I do other important subjects. What's the right way to distribute my priorities? Well, again, depends on the situation. If you are comfortable in terms of maybe it's not about money. Let me think twice. Depends on your strategy. If you're going to be a programmer who will just be making money and basically hating the job that you're doing, then you can, I think, ignore all other subjects. Just ignore them. If you are, on the other hand, would like to become, let's say, a researcher, somebody who is gonna be the creator of the ChatGPT next version, then in this case probably you should pay attention to other disciplines, because those disciplines they will help you to become, let's put it this way, the fundamentally developed specialist, the person who knows enough to be to be respected in the community and to grow in the direction of the fundamental software development, research, whatever. And the majority of people are just engineers. They just implement certain things. They implement certain functionality, taking the existing products. They just take whatever was developed before, for example, Java as a language, and the IDE and the Spring framework. They just put all those pieces together, and apparently they create new application, which makes people happy and which makes all of us more, enjoy our life more. But there is a small amount of people, like, I don't know, 5% or maybe a few percent of also software engineers, of computer scientists, who actually created and who keep creating those Java programming languages and the IDEs and everything else. So who do you want to be? You want to be in which category, the first or the second? If you want to be in the second, which is better paid, but it is way more difficult to get there, because you actually need some talent, I believe. You need some, it's not just about completing the course, filling up all the marks and checking and getting the diplomas, and then you become a contributor to the next version of Java. It's not that. It's not how it works. Usually you need some sort of a talent or a lot of passion, a lot of enthusiasm to get to this second category. If you don't want to get there, just don't waste your time on those other subjects and just focus on programming, because that will get you to your bigger salary directly, in a fast way. That's what I think. Next one. Should software development teams follow OKR, Objectives and Key Results Framework? Well, in general, any team should work under some objectives and under some measurement of productivity. Software team, or the team of taxi drivers, or the team of nannies, or the team of I don't know, whoever it is, writers, movie makers. We all need some sort of OKR. We all need some sort of KPI. We want to be tracked. We want to see the productivity of us. And software team is no exception. But of course, it's a debatable. It's a subject for debate. A lot of software developers will tell you that we're not interested to be managed like that. We're not interested to be measured. We don't want our work to be simplified to a set of numbers. And this is the key argument which you're gonna hear from a team if you decide to tell them to introduce some sort of KPI to a team of software developers. They will tell you that it's impossible. That's going to be their argument. They will say it is impossible, and if you make it possible, you will make it wrong. That's just the axiom. That's something that you cannot argue with. And if you try to argue, they will get offended. If you start telling them that actually, you guys, your opinion about yourself is too high. I don't think that you cannot be simplified to a number. Actually, you can. And they will be like, wow, who is this guy? Why are you talking to me like that? So be careful with that. Be careful with introducing those OKR or KPI. Be careful with telling people that you believe that the KPI is a good thing. You will only get a reputation of a rude and unprofessional and weird person. It's better when you are in a team and you talk to other programmers. It's better to keep saying that software development is a very complex. It's a very sophisticated, it's very creative type of activity. It's something that's very hard to measure. It involves a lot of passion, a lot of thinking, deep thinking, blah, 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 all of that. Then everybody will respect you. They will say, oh, that's a smart guy. He's saying, oh yeah, we want to work with this guy. Because basically you are saying, I don't care how you work. That's what you're actually saying. You're saying, I'm stupid enough to not understand how you guys work. And I'm stupid enough to not even try to find out how to manage you. And that's a brilliant manager, right? That's awesome to work for the guy like that. How can you find a better manager than that? Well, provided you don't care who is your manager, provided you don't want to be bothered by the manager. That's the perfect one. It's way more difficult and way more dangerous to work with the manager who actually counts your results and comes to you by the end of the month and shows you the number and actually complains if the number is not high enough and actually stops paying you money if the number is not high enough and actually fires you if the number is not good enough. And this manager is a pain in the back. You don't want to do with that. And so pretend to be the guy who is completely delusional about the productivity. It's going to work for you. Next one. Any plans for the third edition of the EO book? Yes, actually a lot of plans. I'm working on that, and I hope to see some progress very soon. It will be definitely published. It's in the plans. It will. Next one. What do you think? Could you be so productive engineer if you have wife and kids? Well, I did have wife for many years. I've been married for like 9 years. So I know how it is. And the product and kids, I don't have kids, yeah, but I think the family life definitely affects the productivity, definitely, because family life is a separate project. You have to invest there, not only money. You have to invest your time. You have to invest your energy. You have to invest your stress. You are stressed when you deal with other people. You need to deal with them somehow. If it's one person, the wife, or if it's the number of kids, then you work there. It's like a separate project. The question is whether you have enough spare resources for that. So I think my productivity would be lower, definitely, as an engineer, as anything you do. But maybe at the same time, well, that's what some people say. Maybe the family life gives you something back and actually, for example, motivates you. That's what people say. When you have wife, when you have kids, then you have a reason to work. You have the problems which you need to solve, because not enough money, not enough time, not enough this and that. And in order to solve those problems, you have to work. Some programmers don't have enough motivation. They just don't know why they work. They have enough, the salary which they're getting is enough to live the normal life, but that's it. What's the point of becoming too successful, of becoming a millionaire? What's the point of becoming a startup founder? What is it for? If I already have my TV, I have my room, I have my computer, I have my breakfast, I have my lunch, that's it. That's all you need, basically. Maybe, but in my case, I don't have that problem. I do know the problems and I'm interested to solve them. I don't need extra problems to solve even more problems. I have enough of my own problems and I don't have enough time to solve these problems. Sort of. Next question. Do you think about Nobel Prize in Physics to Geoffrey Hinton, the godfather of AI? Is it about physics? Well, I don't think it's directly about physics, but in general, the Nobel Prize is more about politics, not about actual contribution of those people. It's very political instrument of affecting the society. Don't treat it as an open competition where there are rules and people supply, and then according to the rules that some judges, they just compare objectively and they just decide who deserves, who don't deserve. It doesn't work like that. It's just a small group of people who are highly impacted by the political forces of the current global government, and they do what they're being told to do. And of course, the people who get those rewards, they are definitely reputable scientists. That's for a fact. You can Google them. You can see their papers published. You can see their Hirsch index. They are not nobodies. They are well-known scientists. But they are definitely not objectively selected scientists among their domain. This is not a fair competition. Absolutely not. What I think about physics, is AI about physics? Well, to some extent. Of course, it's not fundamental physics. They didn't discover anything from the nature, but we can say that maybe they did. Because actually this artificial intelligence which we have for the last 2 years, the large language models, is close to physics. Maybe this is how our brains work. And maybe the discovery of this, in general, the neural networks, maybe this is a simulator, a model, an approximation, an abstraction maybe even, of the brains of the nature, of what we have in nature, in physics. Well, whether it's physics or not, but and it seems that it is. It seems that something like that exists in, maybe not in humans, maybe we have something more sophisticated, but in primitive animals or insects, probably it's very close to what they have. So maybe yes, maybe it's physics. Next question. What is your opinion on DHH? DHH, I know one thing, DHH. I know DHH is the guy who invented Ruby on Rails. If you're asking me about him, then I think he's and also he created the 37 Signals or something, the startup. So the guy affected a lot of things on software development domain. So I respect him, even though I don't like Ruby on Rails. I said it many times. I think this framework is It's similar to Spring Framework. It's with the same principles, which are not object-oriented principles, in my opinion. But that's a separate story. Next question, how do you feel after your trip to Altai? Oh, that's a good question. Was it your first time there? How do you like the nature, atmosphere of these places in general? Andy, thanks for the question. Well, I did like it to some extent, even though it was quite tough, because like I said, I had no food for 7 days. And people say it's good for your health because somehow your body is supposed to digest itself because there is nothing else to digest. So the body decides that now it's time to eat itself, not itself, but the reserves. They eat something which was preserved before, and I think it's just reasonable. What else to do? And the body eats the weakest part of itself, the weakest cells, because they cannot fight for themselves, and that's why the stronger cells kill the weaker cells. And that's why your body, when this process is finished, then your body is cleaner to some extent. And this is what's called autophagy. And this autophagy mechanism was actually discovered, and even the Nobel Prize, which we just talked about, was given to the authors of this discovery. I kind of believe in that. It looks reasonable, so I decided to try. Decided not to lose weight. I don't have problem with weight. I was okay with my previous weight, and I'm okay now. But let's see whether it changes something in my health in general. About Altai, I say it's quite average, to be honest, in my experience. Even the nature, it looks normal, just nothing extraordinary. I mean, it's just a forest, and there's river, and there are people, and there are shops, mostly owned by Moscow people, not by local people. And there are hotels also built by Moscow people, not by local people. So it's not something which you can claim to be the place with a very local and very natural experience, very native experience. It's just a forest with a river. Nice nature, I would call. I would probably go again if I have time next year. Next question. How would you model an event sourcing in real object-oriented programming? Event sourcing. If I would know what is event sourcing. Well, probably you mean that we have like the class, which is the subscriber, and then there is a class which is the provider of events. So I'm supposed to subscribe to that, and then when something happens, then I get the event, something like that. Then I would still use classes, objects, and one object just registers itself, and another object just calls that object, something like that. I'm not sure what exactly is event sourcing. Maybe I know how it works, but the name doesn't trigger the bell immediately. Next question. Would dependency injection still be useful if you could easily mock any dependency? Well, I believe dependency injection is in general the mechanism of wiring together different, let's say, objects or modules. Without dependency injection, every module would just know who to talk to. With dependency injection, the module doesn't know who it is supposed to deal with. All the dependencies, all the friends, all the connections, they are injected when the module is created. And that's the beauty of dependency injection, because you can deal with this module faking the connections, injecting whatever you want to inject there, instead of letting the module decide who are his friends. And of course, dependency, so your question kind of, maybe I don't understand the meaning. Let me check the question in VK. In VK, we have how many viewers? Actually, we have 5 people there, not so many. The question is, what is the current state of Zold, of the Zold currency? Well, it's an open source project still. It's live, it works, it has a number of servers where everything runs, but we don't have any payment volume, so we don't use it actively, and people don't use it, but the project is alive, and maybe one day we will get it back to life if we want to do that. It's still quite stable, and sometimes we check whether the CI works there. We check whether some bugs are being fixed. It's an open source, but we don't abandon that. We don't forget about it. But it's not live. I mean, it's live, but it's not being actively used. Can you estimate the role of programming in scientific research? Oh, it's huge. I think any researcher must be a programmer to some extent. In order to run the experiments, in order to check how data is connected to each other piece to piece, you need to be a programmer. You don't need to write system code, system libraries, but you need to be able to simulate, for example, your hypothesis. And for that, you need to write a few files in Python. I think it's mandatory to be a programmer these days in order to be a researcher. Next question. I think that Uncle Bob made a lot of hard to programming than polite. And those books has a lot of water rather than good knowledge. Do you think about it? Oh, actually, no. I've heard that opinion, that the books of the Robert Martin, just as you call them, water, meaning that the books are full of something that is not important and there's not too much information. I don't think so. Well, first of all, keep in mind when those books were written, especially the Clean Code book. This book was one of the first books of that kind where the authors were able to summarize what is good code, how to write code in a good way. And there were not so many books at that time. So he was one of the first. Keep it in mind. Of course, now, today, when you read those books like 20 years after they were published, you look at it and say, hey, I know all of that. It's just a common sense. What's the point of saying that? But it is common sense for you now. Continuous integration 15 years ago was not common sense. It was innovative, bright, interesting, and very challenging idea. People didn't like the idea of continuous integration. Many people. There were many teams who were not writing unit tests at all, and they were against unit testing. So get back to the book of Kent Beck, where he said that test-driven development is the way to go. Yes, now it's just common sense. What's the point of writing this book? But back then, it was a quite strong message to the society, to the community, that if you don't have tests and if you don't write them before you write the code, then you're doing something wrong. Everybody was just, what? We don't have tests because we don't have time for that. We're programmers. We're serious programmers. We're not kids to play around with those tests. That was the attitude. The same for the Clean Code book, for the Robert Martin. There are many, many important things. Well, I believe it's one of the fundamental books, even though it's written in the style which is quite fun. But that's even make the book better. Roll back in time, 20 years backward, and see what books were published at that time. You will see garbage, Clean Code book, then garbage. Because all those books, they were classic, traditional, boring books with long diagrams, with boring advice, which people were reading and not understanding how exactly to stop hating the code I write. And then Clean Code. Robert Martin said, hey guys, we can make our code fun. We can make it look better. We can make it nicer. And then serious programmers with big beards, they just said, no, that's something that we don't want. But now those guys are dead. And the young generation, we just feel that this is how we code. We just know that this is the common practice. So I believe Robert Martin did a lot of contribution. Even though I do not agree with everything he said. I even have a blog post where I argue with him about something that he did. That's okay, but I respect him a lot. I mean, his work. Next one. If you're using IDE as a plain text editor, why didn't you switch back to VIM? What's the point keep using IDE? IDE are pretty heavy and VIM is fast and lightweight. I tried Emacs. I tried VIM. I kind of like the visual interface. Even though I like console, I like to work in the terminal, but for the editing of the text, I prefer a special app, a special window where everything feels more like GUI, more like graphic user interface instead of old school text interface. Just the matter of taste. Okay, one last question, we're done. So in the years of work as a software engineer, what food hacks you found out during work? Food hacks, nice. Basic example, hydrate enough, but maybe you know some interesting funny hacks. Oh, there's only one hack. I don't. I have no hacks. I eat whatever it is. I eat everything. And well, when I code, I like to drink tea. I mean, and I drink it, if I can, with milk. Tea with milk. That's my drink when I code. That's it. That's my food hack. Thank you very much. Thanks for coming. Appreciate it very much. See you next Friday, same time.